human beings have always observed that if you have an object that is moving, so this is a moving object traveling to the right here, that it seems to stop on its own. That if you do nothing to this moving object on its own, this object is going to come to a stop. It is going to come to rest. And on the other side of things, if you want to keep an object moving, you have to keep applying a force to it. We've never in our everyday experience seen an object just keeps moving on and on and on forever without anyone acting on it. It seems like something will always stop. And this is why for most of human history, probably prehistory, but we definitely know the ancient Greeks all the way until the 1600s, all the way until the early 1600s, so for at least 2,000 years, the assumption was that objects have a natural tendency to stop. Objects have tendency to come to rest or to stop. And if you want to keep them moving, you have to apply some type of a net force to it. Apply force. And once again, this is completely consistent with everyday human experience. This is what we've all experienced our entire lives. But then these gentlemen show up in the 1600s. And you might be surprised to see three gentlemen pictured here, because this was about Newton's first law of motion. And indeed, one of these gentlemen is Sir Isaac Newton. That's Newton right over there. But these other two guys get at least as much credit for it because they actually described really what Newton's first law describes, and they did it before Newton. This is Galilei, and this is Rene Descartes. And they described it in different ways, and Newton frankly gets the credit for it because he really encapsulated it into a broader framework with his other laws and the laws of gravitation, which was really the basis of classical mechanics and seemed to describe, at least until the 20th century, most of how reality actually worked. And their big insight, and it was very unintuitive at the time, so now we come to the 1600s, is that these three gentlemen said maybe it works the other way. Maybe objects have a tendency to maintain their velocity, so their speed and their direction. Have a tendency to maintain their velocity. And if their speed is 0, they'll maintain that restfulness unless they're acted on by an unbalanced force. Unless acted on by unbalanced force. So completely the opposite way of thinking. For 2,000 years, objects tend to stop on their own. If you want to keep them moving, apply a force. These guys say objects have a tendency to maintain their motion forever, and the only way that you're going to stop them is if you act or accelerate them or change their velocity, so either their speed or direction some way, is to act on them with an unbalanced force. But you might be saying, hey, come on, Sal, what's going on? You just went through this. You said for most of human history, and including my own personal history, this is what I observed. How can these guys say that this thing has a tendency to go on forever? This seems to break down. And their big insight was, well, maybe these things don't have by themselves a tendency to stop, but because of interactions with their environment, forces are being generated that are acting against their motion. So when you think you're just leaving this thing alone, there's actually a net force that is trying to stop it. And this particular example right over here, the net force is the force of friction. It's the interaction between the block and the ground. So this thing, when you think that you're leaving this thing alone, you actually have a net force that is going against its motion, which is the force of friction. And these guys realized that because they said, look, if it was an innate property of the block, regardless of the environment, it should kind of always come to a stop in maybe a similar way. But they saw if you made this surface a little bit smoother and a little bit smoother, this thing would travel further and further. And maybe if you eliminated this friction, this made the surface completely frictionless, completely smooth, this thing indeed would travel forever. And they didn't have the luxury of launching satellites and doing things in deep space. So it was a very, very, very unintuitive thought experiment. And then you might say, well, what about this other thing? What happens when I am applying a force? Because in my everyday life, if I want to drag my TV set across the room, I apply a force to it. And what these guys would tell you is all you were doing, if you were keeping the velocity of that TV constant, all you were doing was counteracting this net negative force. So if this was a TV dragging across your carpet, this is the force of friction acting against the motion of the object. And so you are essentially just balancing it when you push it. If you balance it perfectly, you will be able to maintain its velocity. If you want to accelerate it,